All right, the first oxidation reduction equation I showed you was easy. The second one, considerably more difficult. And I showed you a couple techniques used for balancing these, called inspection and adding half reactions. The one I've had the most success with over the decades is what I call the bracket method. And I put brackets or lines between the elements on opposite sides of the reaction, showing their changes in electron or oxidation state. And it's been markedly successful, so please follow along. In the equation indicated here, you got manganese on the left side exhibiting a charge of a positive 7. Oxygen being fairly dependable is a -2. There's 4 of them. That's 8 minuses. 1 minus is accounted for by the charge of the polyatomic NO4, 1 minus. Thus, the magnesium rather, not magnesium, but manganate ion on the left side is a positive 7. And on the right side, it is a positive 2, because sulfur is a -2. So here you gain 5 negative charges because it's gone from +7 to +2. Gained 5 negative charges. Up above with the sulfur's 2 minus, and it goes to this one. Well, it's 2 minus there, so there's no change. But sulfur goes from there to sulfur elemental or by itself. And I said from the beginning that all the elements have 0 charge. So it goes from a 2 minus to a 0, meaning that it loses 2 electrons. Now, at this stage, I recommend that the students do what I call cross multiplication. And that's kind of a simplified phraseology to mean that you multiply the manganese by the number of changes for the sulfur, and the sulfur by the number of changes of the manganese. And this will produce a 2 in front of the manganese and a 5 in front of the sulfur. Excuse me. Now, the rest of this is, in essence, you have the problem solved at this juncture. Now, to balance the oxygens and the hydrogens is absolutely no problem. If you notice, I've stipulated these are aqueous, so the whole doggone thing is an aqueous reaction, meaning you have an unlimited number of components of water, which means hydrogen ions and hydroxide ions available. So if you go through to balance this, it's actually pretty doggone straightforward. You put 8 in front of the water, giving you 16 hydrogens, and you have 16 hydrogens over here. Now the oxygens, you have 8 oxygens there. 2 times 4 is 8 there, 16 oxygens. Now, on the surface, you'd say, okay, it's balanced. No, it's not. 5 sulfurs, but what about these 2 sulfurs? You must include them. So, to balance this, you will have to erase your 5 and put a 7 in to balance the number of sulfurs. And that, in essence, is the bracket method that I use quite serviceably, because the students understand the change in oxidation and the cross-multiplying, and it makes a heck of a lot more sense normally. Balancing water is pretty straightforward. because you can add extra waters and extra hydroxides. So I hope that helps you out.